So what are the factors that may influence the size of particles obtained during a pharmaceutical production? So there are different factors, but the two factors that I want to highlight in this lecture are the type of excipients and the processing parameters. The type of excipients used in any formulation can vary, okay, but as an example, the surfactant or the surface active agent that is used during the production. Surfactant is a type of material that will help to stabilize a formulation. So there are different type of surfactants out there, and which surfactant being chosen will produce a different size of particles. And surfactants at different concentration will also influence the size of the particles obtained. So thus it is very tricky, and it may give false indication if we don't use any statistical analysis to evaluate the difference between each surfactant or the influence of each surfactant on the particle size obtained. We will discuss more after this when we look into the different examples that I will give to you. Okay, and the second factor that I want to highlight is the processing parameters. There are different processing parameters that may be chosen during the production of particles. As an example, if we choose to produce the particles by using a homogenizer, okay, the homogenization method or the homogenizer has a different speed, okay, 10,000 rpm or 20,000 rpm or 5,000 rpm. So each rpm or speed, each rpm or speed may produce a different particle size. So how can we know the difference are significant? This can be done through statistical analysis. So it is very important for us to conduct statistical analysis because from there we will be able to determine the parameters that affect the size of the particles produced, okay, and we would be able to make informed choices on the formulation parameters. Okay, statistical analysis may be conducted in two ways. Number one is by via description. Means description is very straightforward. We will describe the mean, mode, and median. Okay, we describe the sorting of the particles, and from here we will have a brief idea, okay, or a general idea on the character of the particles that we have. We have a simple numeric summary, and from there we will know that the most particles in this group of or in this batch of powder is from, let's say, 10 micrometer. Okay, if we refer to this figure, okay, the highest number of particles or the most number of particles is in the size of about between 5 to 10 micrometer. So this is the description that we can have from such data. The second way is by conducting statistical analysis, t-test, ANOVA, okay, and from here we will be able to determine which parameter influence the particle size. Okay, as an example, does the stabilizer or the surfactant affect the size of particles obtained? Does the type of stabilizer A or stabilizer B or stabilizer C, okay, if you have 3 stabilizers, okay, from if we have such data, we can determine the significance difference between the three particles size that we obtain by using one-way ANOVA, okay, or if we want to know more, we may use two-way ANOVA if we want to know the effect of the stabilizer on the size of particles obtained by using 4 different processing methods. So it's more complicated, but it can be done. Okay. So from such analysis, the p-value will be the important parameter. Okay, so the p-value that will be obtained can tell us whether the difference between the particle size are significant.